Imagine a universe so vast and mysterious that it challenges everything you thought you knew about reality. What if the secrets of the cosmos could change the way you see your entire existence? Today, we're diving into 25 mind-blowing facts about the universe that will completely transform your perspective. Buckle up, space is stranger than you think. Welcome to Truthquench, where curiosity meets cosmic wonders. If you love discovering fascinating facts about space and beyond, be sure to subscribe and hit that bell icon so you never miss a cosmic revelation. Let's start with a mind-bender. The observable universe stretches a staggering 93 billion light-years across. That's a distance so vast that even light, the fastest thing we know, takes billions of years to travel it. Think about that for a second. The light from the farthest galaxies we can see started its journey long before Earth even existed. And what's in all that space? Stars. So many stars. In fact, there are more stars scattered across the universe than all the grains of sand on every single beach on Earth combined. Next time you're at the beach, pick up a handful of sand and try to imagine each grain as a sun, many with their own planetary systems. It's an incredible thought. Now, let's talk about density. Neutron stars are the collapsed cores of massive stars, and they are unimaginably dense. If you could scoop up a piece of a neutron star just the size of a sugar cube, it would weigh around 1 billion tons here on Earth. That's like cramming the weight of Mount Everest into something you could hold in your hand. But what about the opposite of stars? Black holes. We often think of them as cosmic vacuum cleaners. But did you know they can slowly evaporate? Thanks to the brilliant Stephen Hawking, we now understand that black holes emit a faint glow known as Hawking radiation over an incredibly long time. This causes them to lose mass and eventually they can disappear completely. Here is a fact that really messes with our perception. Most of the universe is completely invisible to us. Everything we can see, stars, galaxies, planets, makes up only about 5% of the cosmos. The other 95% is composed of dark matter and dark energy, mysterious substances that we can't see or touch, but we know are there because of their gravitational effects. We're literally surrounded by an invisible universe. Speaking of time, our universe is old, really old, about 13.8 billion years old, to be precise. This means when we look at distant galaxies, we're not just looking across space, we're looking back in time. The light we see from a galaxy 1 billion light-years away left that galaxy 1 billion years ago. It's like having a time machine with a very powerful lens, and the number of galaxies is just as staggering. Astronomers estimate there are over 2 trillion galaxies in the observable universe. Each one of those contains billions, sometimes trillions, of stars. Our own Milky Way is just one tiny drop in an unfathomably vast cosmic ocean. How did it all get so big? It all started with a bang, but what happened right after is even crazier. In the very first fraction of a second after the Big Bang, the universe underwent a period of cosmic inflation. It expanded exponentially faster than the speed of light, growing from subatomic size to something astronomically large in an instant. This rapid expansion shaped the vastness we see today. When it comes to size, our sun feels huge to us, but it's a dwarf compared to some other stars. Take UY Scuti, one of the largest known stars. It's so enormous that if you replaced our sun with it, its surface would extend out past the orbit of Jupiter. It's about 1,700 times the size of our sun. Not only does space have huge objects, but it also has forces that bend reality itself. Gravity, for instance, actually warps time. According to Einstein's theory of relativity, the stronger the gravity, the slower time passes. This means that near a massive object like a black hole, time literally slows down compared to time on Earth. While black holes are hot at their singularity, the universe also has incredibly cold places. The coldest known place in space is the Boomerang Nebula. At a chilling -272 degrees Celsius, it's just 1 degree above absolute zero, the theoretical temperature where all atomic motion stops. It's colder than the faint background glow of the Big Bang itself. Let's move from cold to sparkly. On some exotic exoplanets, scientists believe it might literally rain diamonds. On planets like Neptune and Uranus, the intense pressure and extreme temperatures in their atmospheres could crush carbon atoms, forming solid diamonds that then rain down toward the core. Talk about a cosmic treasure hunt. Back to the big picture, the universe isn't just expanding, its expansion is accelerating. Something is pushing everything apart faster and faster. Scientists have named this mysterious force dark energy, and it's one of the biggest puzzles in modern cosmology. It's as if the universe has its foot on the gas pedal, and we have no idea who's driving. Even though the Big Bang happened billions of years ago, we can still see its afterglow. This faint glow, called the cosmic microwave background radiation, permeates all of space. If you tune an old analog TV to a dead channel, a small percentage of that static is interference from the birth of the universe. And contrary to the popular idea of a vacuum, space isn't completely empty. The void between stars and galaxies is filled with tiny particles, radiation, and magnetic fields. It's a very thin soup of matter and energy, but it's there, weaving through the cosmos. So, with all our incredible technology and knowledge, you'd think we have a pretty good handle on what the universe is made of. But as we mentioned earlier, about 95% of its mass energy remains a complete enigma to scientists. Dark matter and dark energy are just placeholders for concepts we don't yet understand. We've only just begun to scratch the surface of cosmic reality. While we're pondering these mysteries, our entire solar system is on a wild ride. We're hurtling around the center of the Milky Way galaxy at a mind-boggling speed of 828,000 kilometers per hour. Even at that incredible speed, it still takes us about 230 million years to complete one full orbit. In the distant universe, there are objects that shine with unimaginable brightness. They're called quasars, and they are powered by supermassive black holes at the centers of galaxies. As gas and dust spiral into the black hole, they heat up and release tremendous amounts of energy, making the quasar so bright it can outshine its entire home galaxy. Here's a question that philosophers and scientists have debated for centuries. Is the universe infinite? We don't know for sure. It's possible that the universe extends endlessly in all directions, with no borders or edges. If that's the case, then somewhere out there, an infinite number of possibilities could be playing out. Some of the most powerful events in the universe are gamma ray bursts. These are massive explosions that unleash colossal amounts of energy, sometimes more in a few seconds than our sun will emit in its entire 10 billion year lifetime. They are the brightest electromagnetic events known to occur in the universe. Another brilliant cosmic event is a supernova. When a massive star reaches the end of its life, it can explode in a spectacular fashion. For a brief period, a supernova can outshine its entire galaxy. These explosions are also crucial for life, as they spread heavy elements like iron and carbon across the cosmos, which are the building blocks for planets and, eventually, us. What if there were shortcuts through space? That's the idea behind theoretical wormholes. These are hypothetical tunnels through spacetime that could connect to distant points, offering a way to travel billions of light years in an instant. While they're a staple of science fiction, we have yet to find any evidence that they actually exist. Our galaxy is on the move, but it's not just orbiting. The Milky Way, along with our neighboring galaxies, is being pulled by a mysterious gravitational anomaly called the Great Attractor. We can't see it directly because it's hidden behind the plane of our own galaxy, but we can detect its massive gravitational pull from billions of light years away. If one universe isn't mind-bending enough for you, how about an infinite number of them? The idea of parallel universes or the multiverse suggests that our cosmos might just be one of many, each with its own set of physical laws and realities. It's a fascinating theory that pushes the boundaries of what we consider possible. Finally, what is the ultimate fate of our universe? Scientists have a few theories, and they all sound pretty dramatic. It could end in a big freeze, where expansion continues until everything is cold and dark. Or maybe a big rip, where dark energy becomes so strong it tears apart galaxies, stars, and even atoms. Or perhaps a big crunch, where gravity eventually wins, and the universe collapses back in on itself. The future remains unwritten. The universe is a realm of astounding wonders and mind-defying mysteries, constantly reminding us how much there is still to learn. If these facts changed your perspective, give this video a thumbs up and share it with fellow curious minds. Don't forget to subscribe to Truthquench for more eye-opening explorations. Until next time, keep looking up and stay curious.